what do we mean by abstraction layers? Like with regards to tool integration and modularity, what do we mean by abstraction layers? The definition of abstraction layers. So abstraction layer is basically a layer that hides tool complexity from the agent. So abstraction layer is a layer that hides the tool complexity from the agent. So abstraction layer, it ensures the agent interacts with a stable, high level interface rather than wrestling with the specific, often messy implementation details of underlying code or APIs. So the meaning of abstraction layer is that it is a layer that hides the tool complexity from the agent, wherein because of the abstraction layer, now the AI agent has nothing to do with the internal details of the tool, like how the tool will work, what API it will call. It has nothing to do with that. AI agent just need to know some self-descriptive metadata about the tool, like what is the name of the tool, a description like what that tool can do, the input and the output, like what input parameters it can take and what output parameters it will generate in response. That's it. And AI agent, it has nothing to do with the internal working of the tools, like what APIs it will be calling, how it is working, what is the implementation detail. So we are able to hide it because of the abstraction layer. So if you consider a scenario, just imagine if there would be no abstraction layer. So without abstraction layer, agent, the AI agent had to wrestle with the actual API implementation details, actual implementation details of the tools. Without abstraction, AI agent had to wrestle with the specific, often messy implementation details of the tools, wherein it had to understand the API endpoints of a tool, the parameters, the formats, the schema, the JSON outputs, whether the API will take a GET request or a POST request, authentication tokens, all that stuff. So without abstraction, agent must know all the information about the tools, like the implementation details as well. And definitely it can be very messy. It can be very messy. But with abstraction layers, with abstraction layer, agent just need to know the some self-descriptive metadata about the tool, like the name of the tool, what input parameters it can take, what output response it will generate, and a natural language description telling about the capability of the tool. That's it. With abstraction layer, agent need not to be worried about the implementation of the tool. So how things work is, we have an agent knows the name of the tool and the input parameter. So agent will directly just call that tool. It will call the tool and pass the city. That's it. And here abstraction layer is in action. Because of this abstraction layer, now the agent is totally unaware about the implementation detail. So implementation detail is hidden from the agent. Agent just know that, okay, this is the name of the tool and I have to pass the city. So it will just pass the city. That's it. And underneath, actual API implementation calls will be done by the tool itself. The tool will call the weather API, and now authentication tokens, get request, post request, that all will be taken care by the tool. Agent need not to worry about that. So tool will call the API, generate and response, and the tool will just give the response back to the agent. So this is what abstraction layer is about. So with abstraction layer, the agent only deals with the simple request and the abstraction layer handles the mess. So this is what is abstraction layer is. And now it's very clear that when we talk about tool integration and modularity, abstraction layer plays a very, very important role. So if we look at the benefits of the abstraction layer, benefits of the abstraction layer. So abstraction layers, it simplifies the reasoning, because we know that abstraction layer, it hides the implementation detail of the tool. It hides the technical complexity behind simple APIs. So abstraction layer, basically it is reducing the cognitive load on the AI agent, because AI agent, it simply has to call a tool, the name of the tool along with the input parameter. That's it. Now the API, the implementation, like how the API will be called, the authentication token, get request, post request, that all will be taken care by the tool itself because of the abstraction layer. Abstraction layer hides the complexity from the AI agent. Because of that, the cognitive load on the AI agent is reduced. So basically, abstraction layer, it does something called as hierarchical decoupling. It decouples the tool from the implementation of the tool. And this hierarchical decoupling, it breaks global tasks into smaller, locally tractable problems that are easier for a large language model to solve. So this is something very important. So because of abstraction layer, now the large language model can very easily break a global task into smaller, locally tractable problems. So global task can be broken down into sub problems, and every sub problem can be sent to particular tools, and they can be locally watched by the large language models, AI agents. So now it's very clear to us that abstraction layer, it simplifies the reasoning of the LLM of an AI agent, because now AI agent need not to worry about the implementation details of the tools. AI agent just need to know that what a tool can do, and AI agent will just delegate the task to a tool, because of which we are reducing the cognitive load via simple APIs. And because of that, now AI agents, the large language model, it is aware of all the capabilities, and if it has to perform a big task, it can break it down into small tasks and send those small tasks to particular tools and get the work done via a process of hierarchical decoupling. So we saw that abstraction layer, it simplifies the reasoning. Abstraction layer, it also reduces the errors. Now let us try to understand how abstraction layer reduces the errors. So see, abstraction layer, it enables better validation and guardrails. So with abstraction layer, errors can be caught and handled within the abstraction layer before they ever reach the core system. So see, the idea is that abstraction layer, it hides the implementation of the tool from the AI agents. Now let us suppose any problem is there while execution of the tool. So since tool execution is decoupled from the large language model, since the tool execution is decoupled from the reasoning because of the abstraction layer, and if any problem is there in the tool execution, very easily it can be identified, very easily it can be said that the problem is in the tool and not the agentic AI system, because tool is separate from agentic AI system. Tools are pluggable, so we can better validate, and we can add guardrails also, because we can add specific guardrails for particular tools, and errors can be caught within the abstraction layer itself, and we can avoid those errors from propagating to the core system. And this is a very powerful feature. So abstraction layer, it can handle, it can catch the error. Like while we are executing a tool, if any error occurs, it will be taken care by the abstraction layer. Abstraction layer will avoid those errors from to propagate to the core system. So this is how abstraction layer plays a role in reducing the errors. And also any changes made to the tools, like changes to the internal implementation of a tool, they are also isolated. We know that tools are independent of the agent AI system. Any changes you make in the tool, it will not have a ripple effect on the agent AI system. So tools, internal implementation of tools are isolated from the agent AI system, and we are able to isolate it because of the abstraction layer. So as long as interface remains the same, agent logic does not need to change, which prevents regressive bugs. So this is very important. Abstraction layer, because of the abstraction layer, we are able to decouple the tool execution from the reasoning, from the LLM, from the AI agent, and hence we are able to prevent regressive bugs wherein any error during the tool execution can be handled by the abstraction layer itself. It will not get propagated to the core system, and hence we are preventing the regressive bugs. Now, abstraction layer, it also enables tool swapping. Abstraction layer, it enables tool swapping. So abstraction layer, it makes the agentic AI system vendor agnostic. So the idea is that it supports parallel development. The meaning of this is parallel development. Like we can have one team which can work on a new, more efficient version of a tool. So we have a team A which is working on a new efficient tool version, and we can have a team B in the same time it is using agent functions with stable interface. So that is what is tool swapping is. So the idea is that I will give you even more relevant example to understand it. Tool swapping, it's a very important concept. So see, the idea is that because of the abstraction layer, now the AI agent has nothing to do with the tool implementation. AI agent has nothing to do with the company of the tool. Like I am using a tool of Microsoft, Oracle, Google. AI agent has nothing to do with that. AI agent just know that these are the tools which I can access because of the abstraction layer. Now, if as a developer I feel like I need to use a new tool in the market, I have to replace an existing tool with a new tool. Very easily I can do because of the abstraction layer. Because of the abstraction layer, very easily I can swap tools. And hence, my agentic AI system will become vendor agnostic. Let us suppose I am using a particular tool of a company and now it is charging me high. It is charging me high. Then I can very easily swap that tool with any other vendor because my system is vendor agnostic because of abstraction layer. Because now the agentic AI system is very much isolated from the tools. It is like plug and play. I can very easily plug new tools. I can replace existing tools. I can remove existing tools because of the abstraction layer. Abstraction layer hides the implementation detail of the tools from the agentic AI system. So abstraction layer enables the tool swapping. Now let us look at an example to get a clear picture. So let us suppose I have a tool. The name of the tool is get weather, and it is taking a parameter called city. Now the AI agent just need to call this tool get weather pass the city, and what is happening inside it, AI agent is totally free from that. AI agent has nothing to do with how this tool will get executed. AI agent just know that what this tool can do, what is the name of the tool, and what inputs it has to supply. That's it. Now, once this tool is called, the abstraction layer will take care of the execution of it. So once this tool is called, weather API will be called, and this implementation detail is hidden from the AI agent because of the abstraction layer. So this is how abstraction layer plays a very important role in tool integration and modularity. Abstraction layer enables decoupling of the reasoning with the execution. Because of the abstraction layer, we can decouple the AI agent with the tools.